Iconic crossings are rapidly evolving beyond concrete and steel. The future of infrastructure is now incredibly intelligent and responsive. Iconic crossings are rapidly evolving beyond concrete and steel. The future of infrastructure is now incredibly intelligent and responsive. Imagine bridges actively monitoring their own health, 24/7. Smart bridges utilize advanced technology for ultimate public safety. They dynamically adapt to environmental shifts and heavy traffic loads. This technological revolution transforms how we build and maintain infrastructure. Our future crossings become safer, more efficient, and truly sustainable. This innovation promises resilient, long-lasting urban connections for all. It truly marks a significant leap from static structures to dynamic systems. These advancements ensure our vital connections thrive for ages. Modern bridges now integrate thousands of advanced IoT sensors. These tiny devices collect real-time structural performance data continuously. They diligently monitor vibrations, temperature, and material stress levels. Data streams continuously, detecting even the smallest anomalies quickly. This proactive approach prevents unexpected failures and costly future repairs. For instance, the Netherlands Living Lab Bridge tests new smart sensors. It gathers crucial data on composite material performance daily and hourly. This invaluable information guides future material development and design. Artificial intelligence processes this vast dataset almost instantly. AI algorithms predict potential structural failures long before they occur. They analyze complex traffic patterns, optimizing bridge lane usage efficiently. AI also identifies structural weaknesses needing urgent maintenance attention. For example, IBM's AI solutions optimize urban traffic flow in cities. This reduces road congestion and wear on critical bridge infrastructure. Predictive maintenance systems extend bridge operational lifespan significantly. Such intelligent systems revolutionize traditional asset management. Autonomous drones now perform precise visual inspections efficiently. These drones access notoriously hard-to-reach areas safely and quickly. Robotic systems can apply advanced self-healing concrete materials. Imagine tiny cracks automatically repairing themselves over extended time. This dramatically reduces human risk and minimizes maintenance downtime. Japan's Shimizu Corporation develops groundbreaking self-repairing concrete. This innovative material uses specialized bacteria to seal tiny microcracks. Automated repairs extend structural integrity beyond human intervention. Digital twin technology creates precise virtual bridge replicas. These twins simulate real-world conditions, testing design modifications virtually. They accurately predict climate change impacts like rising sea levels. Engineers optimize designs for extreme weather resilience using these models. For instance, London's historic Thames bridges could use digital twins. This aids planning for future flood protection strategies critically. Such innovations ensure our vital crossings endure for many centuries. They provide invaluable insights for proactive urban planning. Smart bridges represent infrastructure's next truly significant chapter. They blend engineering marvels with cutting-edge digital technology. These intelligent structures promise safer, more sustainable urban futures for everyone. Our iconic crossings will truly connect generations successfully. Their transformative impact is already shaping tomorrow's landscape. Want to learn more about future infrastructure? Subscribe and join our community.